Okay. So, I gotta flip this around. There's like a pile of stuff there, just set it in there. And you wanna grab, no, you can set it on top of the other stuff. You wanna grab one of those critical thinking ones. Everyone have notes number 4? Notes for unit 4. Okay, so 4 is about polygons, where we're gonna start with triangles and then we'll add additional polygons in there. So a polygon is any closed figure with straight lines, so a square or a hexagon or an octagon, those are all polygons. But for right now, we're going to focus on some of the properties of a triangle. So a triangle is a figure formed by joining 3 non-collinear points. So here we have points A, B, C. Well, I guess B and C are collinear, but all 3 of them don't lie on the same space. And it's a polygon. So here's my triangle, it has points A, B, and C. And each point we can call a vertex of the triangle. Okay. The segments of the triangle are the sides of our triangle. So we have vertex of our triangle, sides of our triangle. The vertices of triangle ABC, well, there's 3 points. So remember, we have to list our points with a point in front of it. So point A, point B, and point C. Our sides, well, these are segments. So I'll tell you one side is side AB. What would another side be?
BC.
Side BC. It's a segment B to C. And what's the third side?
C.
CA. Could I have also written it AC?
Yeah.
Sure. Yeah. And in a triangle, how many angles are there in a triangle? There are 3 angles. And I could just call them angle A, angle B, angle C, but they also may be written a little more formally than that. So angle A, which is here, I could call angle BAC or angle CAB. Okay, and remember the important piece there is that A, that vertex point, is in the middle. So A could be called BAC or CAB if I started on the other side. What would be another angle for angle B? What would be another way I could list angle B? ABC or CBA. And then I have angle C here, which I could have also been listed as, what's another option? BCA or ACB. Okay, so just knowing that, like, we could see these parts listed all different ways, our segments, our sides could be flipped around, all means the same thing. So we can classify angles by their, classify triangles by their angle measurements, okay? For example, okay, because this one's not listed down below, so you may want to underline this. An equiangular triangle is a triangle with 3 congruent angles. An equal angular triangle is a triangle where all 3 angles are the same. We'll talk more about that type of triangle in a little bit. We've already talked about acute and obtuse angles. So that should help you know an acute, right, and obtuse triangle. An acute triangle means that all of the angles are acute angles. So what does acute mean? Less than 90, right? All of the angles are acute angles or less than 90 degrees. So maybe, for example, I have a triangle and it tells me that this is 50, this is 72, and that angle is 58. So if visually I can see that all my angles are less than 90, then that's an acute triangle. We all know what a right triangle looks like. Now, a right triangle is not all of my angles are right angles. That wouldn't give me a triangle. That would give me a rectangle or a square. Okay, so an acute triangle is the only one where we're talking all the angles are acute. Once we get to right and obtuse, I can't have more than one 90-degree angle in my triangle. It wouldn't create a triangle anymore. So a right triangle means I have just one right angle in my triangle. And right triangles we really like because we can do things like the Pythagorean theorem with our right triangles. Why can't I, by the way, have another right angle and make it a triangle? What does a triangle need to equal?
90.
Well, this is 90, and then I have these other two angles all together. Does anyone know? What does a triangle add up to? 180. So if I had a 90 here and I had a 90 here, that's going to start forming a rectangle or a square. I wouldn't be able to come back and have a triangle. Right? So all of these, whether it's acute, obtuse, or right, all three of these, when I'm thinking about creating a triangle, okay, all of them, their total angle measurement, oops, need an A there, measurement equals 180 degrees. Okay, triangles add up to 180 degrees if I add up all three angles. Which is why also when I draw an obtuse triangle, I can't have more than one angle that's greater than 90, okay? Because then I would have more than 180 degrees in my triangle between just two angles, let alone the three angles, okay? So an obtuse triangle, similar to a right triangle, has one obtuse angle. Okay, we're just talking about one angle. Maybe this angle is 104 degrees. Okay, one obtuse angle, the others would have to be smaller angles in order for it to only add up to 180 inside my triangle. So I can talk about triangles in terms of the angles that are within that triangle. I can also talk about triangles in terms of their side lengths. So one option is an equilateral triangle, which means all sides are congruent. Equilateral triangle. All of my sides are the same length. Maybe these are all 4 units long. Equilateral triangle. That's like what we get when we have our pattern blocks and there's like a little triangle and all of the sides are the same. So you can create pretty patterns with it because they match up nicely. Okay, those are equilateral triangles. What's an isosceles triangle? Anyone know? Yeah, right. 2 sides that are congruent. So 2 sides congruent. Here's an isosceles triangle. So maybe this side is congruent with this side, but this side's a different length. Maybe this is 8, and this is 8, but this length is 4. Okay, our isosceles triangle, 2 sides are congruent, the third side is not the same length. This is scale triangle. This should say scalene. Scalene triangle. Must have gotten deleted somehow. Scalene triangles. What's a scalene triangle? There's no congruent sides, or all sides are different. There's no congruent sides. So maybe, I'm trying my best here. Maybe I have 9 units here and 11 here and 7 there, but all 3 sides are a different length. Those are called scalene triangles. Don't flip the page quite yet. Many times when we're asked to classify triangles, we're asked to give one from each of these parts. Okay, so it'll say classify the triangle by angle and sides. Okay, so up above this first table, this would be classify by angle measurement. this table helps us classify by sides. Okay, and many times it'll ask you to just go ahead and do both, classify it by angle and sides. So I would have maybe a right scalene triangle. Okay, so I have a right angle and it's a scalene triangle. Or maybe I have an acute isosceles triangle. So I'm using a part from each to classify it. And you'll see that in your homework tonight. Okay. Tell me again, the sum of the angles in the triangle are, what would it add up to? 180. So now we're going to use that to do a little bit of math. So it says, and you'll see this on your homework as well. So it says find angle ABC. That's why we rewrote all of our angles. So ABC means this angle here. How could I find that angle? Do what? Yeah, and figure out what it would be to add 180. So I have this half a triangle here, and I can use 49 and 84, so I'll add those together. So I have 49 and 84, which gives me 133.
No, I think it'd be pretty close. Because we had 46, 49, you get 95, and then you add 84, and that's 179, so you want.
I don't know what you're saying right now.
Oh, I'm sorry, I'm doing it wrong.
Are you looking at the big triangle?
Yeah.
Yeah, so I'm only looking at this half. So if I have 49, 84, here's a triangle. I'm gonna now take this, so that added up to 133, we okay with that?
Yeah.
So now if I know there's 180 in the whole triangle, I'm gonna subtract 133 from 180. So borrow from that 8, 10 subtract 3 is 7, 7 subtract 3 is 4. Gives me 47 degrees for that angle ABC. Do you see how I did that? I'm just using the fact that it's gonna add up to 180 there. Okay, so this plus this, and now I take that amount and I take it away from the 180 in the triangle. Same idea for the other angle, but we got to do a little more work here. Then it says find angle, and there's two ways I could do this. CAD, which is this angle here. So there's two ways, okay? Well, I guess this maybe couldn't be related to this. If we assume that this is all kind of going together, I could use the big triangle and just find this little missing segment, and it would have to add up 180 around. Probably, they may not be the same problem. So let's assume they're different problems. If they're different problems and we have to use this triangle, I only have one angle. Can I find this angle? Yeah, because it's creating a line here. So if this angle over here is 84, well then what must this angle be? Has to add up, remember our linear pairs? Our supplementary? 96, right? 96. Okay, so, and that's because this is a linear pair, they're supplementary. Now I have two angles, I can find the third angle in my triangle. So I have 46 and 96 gives me 152, 180 in the triangle that I take 152 away from gives me 28. Good job, Jaden. Degrees, okay, for that measure of angle CAD. Okay, so finding missing angles. Sometimes we will have to use vertical angles. We may have vertical angles in a diagram, or these linear pairs. So that's from before this unit. Okay, those things are still true. Same idea on 3 and 4, but it's a little bit different setup. So it says, what's the value of x? So each of my angle has an expression. What must all of these add up to again? 180. So I can collect, and it may be easier to collect them all as I write it. Like you could write all one big strip of expressions, but I'm going to go around and say I have 7 here, and I have 2 here, and I have 4 here. So then all together I have 13 x's. And then I have 9 and this 2. So that's going to give me 11. subtract 13 gives me -2. You could have written it all out. I could have said like 7x subtract 13 plus 4x plus 9 plus 2x plus 2 equals 180. I'm taking this. I just combined like terms as I went. Okay. So now add 2. And I get 13x equals 182. Divide by 13. X equals, does 13 go into 182? Let's see, 13 goes into 18 once. Gives me 52, which is 4. 13 times 4 is 52. So this is 14. 13 times 14 is 182. So now what? So we found the value of x. I know I'm running short on time. Then it says find the measure of each angle. Would you be able to do that? Yeah, I just have to go around and substitute in. I'd start with the easier one. So like 2x plus 2. 2 times 14 is 28 plus 2 gives me 30 degrees here. So angle S is 30 degrees. 4 times 14 is 56 plus 9 is going to give me 65 degrees. So angle T equals 65. Now I could either plug in for angle R, or I could also say, well, this is 95 degrees. So that's would leave me with what, 85 degrees for the total triangle, okay, instead of having to plug in one more time. Once I get 2, I can always find 3. I don't have time for the last 3, but I'm not super stressed about them. Same idea, right? I have 2 angles, I can always find the third. You do have homework over the weekend. It's on Google Classroom, but you have your homework packets as well. And it's the same, just triangle totals 180 and classifying triangles that are like a cube of 2 scaling. Oh, does it say just evens? Yes, so do evens because there's something then for on Monday's notes that the odds have those problems only. If that makes sense, you wouldn't be able to do all of them. Yeah, follow whatever this says. This isn't the right year. Did you hear that? Only do evens on homework 19. It says that on the front of here.